Oh, my rating. Guys, is it fine now? No, we are not using Streamlabs. Now we are using just YouTube one. Yeah, it's we are using. I'm coming back to 2200 because I don't wanna try more and I don't wanna try difficult ones or easy ones when it's shit. Let's read some problems here, okay? Little John is a little guy, so we should be able to read many problems easily, okay? Let's try to read this problem. 2200 also should be fine for you people, right? Shitty square, never use it. Recommend it. Recommend to your friend now. Life's fine, I think, bro. How I talked to you before, Zaid and X0B. Bro, you have told that before. Like, don't fish for replies, okay? His diary. Okay, let's read this problem and understand this problem because these problems won't be that good, but they will be easy. They'll be shitty. At higher level, we have good problems. 2200 is not that high level, especially div 3 is bad. But still, let's read the problem. Like, there are shitty problems. Let's try to read the problem still. His diary has n entries showing that he acquired AI pins of fresh milk on day DI. So there are n entries, it seems, showing that he has acquired this many pins of milk on DI. Milk declines in freshness with time and for a maximum of k days. Okay. So it can only be drinkable from among these days, it seems. In other words, fresh milk acquired on day DI will be drinkable from here to here inclusive. Every day, Little John drinks drinkable milk up to a maximum of m pins. Okay. So he has AI pins of here and then he will drink at max M pins. In other words, if there are less than M pins of milk, he will drink them all and not be satisfied. And it's a milk satisfaction day. What do they mean by the freshest? So this is brute force, right? This seems brute force. Like, what do you mean by brute force? Uh, you need not simplify much. The problem is direct, not brute force. This problem seems direct, right? You have these things. I only want to know what do they mean by the freshest. So you have any events. These many pins of fresh milk is there from here to here. Okay. So freshest milk is whichever has occurred in the beginning, right? I mean, newest milk is freshest milk. So he will drink freshest drinkable milk. So it should be drinkable. So freshness decreases, it's gone, and he will always drink the newest milk. Okay. Determine the number of milk satisfaction days that Little John has. Isn't this problem direct? I mean, understand. See, you should be able. You should increase your guys like the videos. No likes it seems. See, you should increase your capacity to read the problem, read multiple problems, try to understand it, try to understand it. Okay. It seems direct, right? But still, there is some difficulty. So how do we overcome that a bit? Like we have to write it well, and then we have to solve it well. So what's the difficulty here? Like these values can be among this. So you have to solve it in O of n. Values less than or equals to 1 is 6. Okay. Days less than or equals to 1 is 6, but then you have to solve it in O of n. Sort them based on days to simplify. Okay. So now you try to find answer for day I. Okay. When trying to find answer for day I, what is the answer for day I? you have some, you may have, so okay, before that I want to say something. You always have, you always have some pins of fresh milk being newest first. You always have this, like x pins of newest fresh milk, and then x minus, and then some other x2. This came latest, and then this came latest, and then this came latest, and then you have x3, and then you have x4. You always have this array, okay, the newest latest fresh milks, and then we always drink the freshest ones, right? And then what happens? As a new day comes, some of them will be removed, okay? When you drink, something will be removed from this direction. So you have this thing, whenever you drink new milk, you drink the freshest one, right? So what happens here? So let's try to see this array. Let's try to see this array. That these things are separated by freshest milk, and they also have when they came. Okay, came on based on day. Okay, so let's say you have number of milks that are, so this k is fixed, right? You have this k length window. Okay, you have this k length window. Number pins on day 0, I mean current day, on day -1. Okay, day -2 up to so on. You always, let's say you always have this thing, number of pins that came on day minus k. Okay, if you are always looking at this array, what happens? Let's say this is the current state. Okay, you will try to drink the freshest milk, right? So you'll try to remove this one, you'll try to make it 0. By remove means you'll try to make it 0, and then you'll try to go and make this thing 0, and then you'll try to go and make this thing 0. If they are already 0, you'll try to go and skip, and then you'll try to make that their 0. Okay, and then what happens? By then, for the next day, this becomes undrinkable, so you remove that, and then you are here, and then you will add a new thing to this. Okay, so that's how it is changing. You remove something, you add something, and then you try to make something 0. Unless then you don't move further, right? So if you can just skip zeros well in this big array, if you can skip zeros well, I think you're good, right? You want a queue where you want to skip zeros quickly. Let's just not maintain any zeros at all. Instead of maintaining the scale length window, never maintain any zero, but have the day. Okay, now we are trying to maintain kar comma day, uh, yeah, pins comma day 2, pins comma day 3. Okay, we are trying to maintain this list. Okay, now we are trying to maintain this list, and then we only have days that can give us fresh milk. What does this mean? These many pins came on this day. That's what it means. Okay, so now, are you guys able to follow? Okay, priority queue is fine, but let's try to see. Yeah, it's being simple, but let's try to, let's like the video, guys. It's difficult to do this shit. I'll solve this problem and then I'll end this. So let's say we maintain these things which are all non-empty. You're trying to maintain this non-empty list somehow. Okay, non-empty queue somehow. What do? You will remove something for a new day. On this day, you remove something from friend. Okay, this seems like a DQ, right? I mean, both sides queue. You should be able to remove. Uh, you should be able to remove from this side, and also you should be able, right? And then you also add. And you also need total sum. If total sum is less than or equals to and total sum, if total sum is less than or equals to, if is less than m, then you cannot remove anything, right? If that is less than m, you cannot remove anything. Else you try to remove few things. In this case, you should not do anything because you cannot remove and then you cannot go back. That is more complexity, right? You cannot remove and then you cannot go back. You have to remove, that's it. So we will maintain this dq, like you can remove from here or you can remove from here or you can add to this side. Okay, or you can even just maintain a vector. Let's reverse this thing. Let's reverse this thing. We have whole days here, and then you have uh, pins on that day. Okay, and then you have pins comma all day one, and so on. Okay, let this just be a vector. And to remove this one, I will maintain an index I. So we are having a vector, right? I will maintain an index I that represents that the start. Okay, that represents the start. Okay, but things will get more complicated again. Why? The days will have gaps, right? You cannot iterate over all days. Can I iterate over all days? Think about that. I mean, all days that have a non-empty thing, you can iterate. Okay, let's think about it. You have some set of days, okay, and then till here it's non-empty. You have to process all these days now. How to process all these days? You will try to see till when this exists, this whole day, till when will it exist. For that many days, you can try to remove. So see guys, it's simple. What it is you have to process things quicker. You have to process things quicker when you're not adding anything. This is the only problem, right? You're not adding anything here, but you have to remove things. So what do you do here? You will try to see as long as this thing exists. Okay, you have to, the idea here is, because the complexity is more, you have to limit the complexity to either indices, you have to limit the complexity to this, or you have to limit the complexity to something else that is getting added. What I mean is you have to involve this. So what do you do? Among all these days, you will split the days until which this is active. So for all these days, this will be active. Okay, and then you will try to remove as much as you can. You will try to remove first m, and then you will try to remove next m, and then you will try to remove as many multiples of m as you can. Okay, you have some summation of these things, right? You will try to remove as many m multiples as possible for all these days. Okay, until this gets removed. After doing that, it's just a simple problem. Do you guys get what I mean? I mean, just a vector, and also using a pointer is enough, right? Just having a vector using a pointer is enough. Do you guys get what I mean? Really? Data structures anyway. It's about maintaining things, right? Should have done this side for a better view. Because light is this side. So guys, we only have one challenge here. We only have one challenge. Okay, it's a simple challenge. When you have this thing in your mind, you have many days to be processed. You have all these empty days. You have all these empty further, right? Seems fine, right? But if you can only proceed till here, and then if you are getting this, we'll again proceed all of these days together, and then we'll try and go and do this. Okay. You will remove. You just want that. Are you guys getting that? It's a shitty problem. Okay, let me write. Let this day be day. Let this be D. Okay. And this be X. At D, this is active. Okay. What does that mean? So we have to remove from this side. What day can this be fresh? This can